Hi Applied Maths students, welcome to our channel Maths Plus U. Now we are doing 12th Applied Maths Unit 3B children, integration and its application. Student support material sums we are doing, this is part 10. What we are going to discuss here now? Some properties of definite integrals. We have the properties, so that property we will just see. One is integral a to b f of x dx. We can change the xy as t and we can apply x dx as t dt. Then the another one, the lower limit and upper limit, we can interchange b to a and the sign we can change it. Integral a to b f of x dx as minus integral b to a f of x dx. Then the third one, integral a to b f of x dx, a to c. In between one answer. For example, I have minus 2 to 2. Na? The in between I have 0. Na? So minus 2 to 0. Then 0 to 2. So like that we can able to split by using this. Then the fourth one, also very familiar, a to b is there. Na? In that property, a and b we have to add, then minus x. A plus b minus x. Integral a to b f of x dx is integral a to b f of a plus b minus x dx. Same way only, here a and b instead of 0 and a is there. 0 plus a minus x. So you will get it as f of a minus x dx. Then integral 0 to 2a f of x dx. Integral 0 to a f of x plus integral 0 to a f of 2a minus x dx. These are some rarely will use that property. Sixth, seventh one, like a even order like that we will check. Suppose 2a minus x we got f of x. Na? We can apply this 2 times integral 0 to a f of x dx. Suppose 2a minus x we got minus f of x. Na? This function itself 0. Then this function, very familiar function, usually we will apply for some sums. Integral minus a to a f of x dx is 2 times integral 0 to a f of x dx. If f of x is even function, the f of minus x, when we will say f of x even function children, f of minus x we got it as plus f of x. Same way we can, so whenever we got even function, sir, what's our even function? For example, you see f of x is x square. Instead of x you apply minus x. Minus x whole square. We got x square. Same function itself we got now. Minus x we applied also, we got f of x now. Then that is a even function. Then we should apply this 2 times integral 0 to a f of x dx. Odd function answer 0. Yes, like that yes. Yes. For example, integral minus 5 to 5. X cube is there. Instead of x, you apply minus. So f of minus x will be minus x cube. That is nothing but minus f of x. Then we can say it is an odd function and that integral will be 0. Clear? Check. So now we are doing the definite integral sums. Exercise 3.5. Evaluate the following definite integral. Sir, what I have to do for subdivision? Like that you ask now. Yes, integral 0 to 3 f of x dx. Okay. Directly we can do what you have to do? 0 to 3 f of x dx they said. X less than 1 they given one condition, x plus 1. Okay. X greater than or equal to 1 they said one condition. Okay, 2x. So the point is 1. So in between 0 to 1, then 1 to 3. Like that we have now 2 intervals. The 0 to 1, what function? X plus 1. 1 to 3, what function? 2x. Till now, okay, check. Then just want to integrate here. So integrate now, x integration x square by 2. 1 integration 1x. Then 2 x square, x integration is x square by 2. 2 you can, it's cancelled. Then start applying children. Upper limit minus lower limit. Instead of x 1 apply 1 by 2 plus 1 minus 0 you apply 0 plus 0. Then 2 as you cancel na x square 3 square upper limit. Then 1 you apply na minus 1 square. So 1 by 2 plus 1 if you take LCM. So 1 2s are 2 plus 1 3. So 3 by 2. Then it will become 0 here. So 3 square 9, 9 minus 1, 8. So 3 by 2 plus 8. Take LCM 16 plus 3 by 2. What is 16 plus 3 children? 19 by 2. Easier check pa. Just what in the sum important? Is going to apply the properly the value x plus 1 and 2x. 0 to 3 we split it into 0 to 1 and 1 to 3. What property of integral understood? 0 that a to what property? A to c plus c to b. This third property only we are applying here. Clear? Check. Okay, first subdivision clear, Amma. Can we go for the second one? I equals integral 0 to 1 x root over 1 minus x. Can you just guess what property is going to apply here? Integral 0 to a f of x dx. Integral 0 to a f of a minus x dx. For your understanding, in that time the property was not necessary, so we are not written in first subdivision. There also we are writing better. But in the second one, it's ultimate you have to apply, then only it be easy. Wherever x is there and a minus x. A is here 1. So x place apply 1 minus x. Root over 1 minus. Again x place 1 minus x. Clear up? Then 1 minus x minus 1 minus into minus is plus x. So 1 minus x root over 1 minus 1 plus x. So that 1 minus 1 gets cancelled and will become 0. And you will get only plus x plus root x alone will be there. Sir, what sir you are saying? Like that you ask now. Let me repeat it. Nothing, children. Where x is there you apply a minus x. Here na what na? Here a is 1. So x here is there. Apply x place 1 minus x. Root over 1 minus. Again x is there. X plus 1. X place 1 minus x. That's it. Minus multiplying inside na minus 1 and plus x. Distributive property. So x place apply 1 minus x. That is what property says to us. Then what we are doing now? 1 minus x into root x. Root x we can write it as x power of. Then start multiplying inside. 1 into x power of minus x into x power of. A power m into a power n, we all know a power m plus n. So x power 1 plus 1 by 2. That is nothing but x power 3 by 2. So apply the integral x power n dx formula. X power n plus 1 by n plus 1 plus c. So x power of, if you apply now, x power of plus 1 by half plus 1 minus 3 by 2 apply now, x power 3 by 2 plus 1 by 3 by 2 plus 1. 0 to 1. So 1 by 2 plus 1 we are getting 3 by 2. Again 1 by 2 plus 1 3 by 2. 3 by 2 plus 1 we are getting 5 by 2. Again 3 by 2 plus 1 5 by 2. Then if you see it, this 3 by 2 comes this side 2 by 3. Again 5 by 2 comes this side 2 by 5. Then apply the value, children. Apply instead of x1. So 2 by 3 whole power 1 power 3 by 2 minus 2 by 5 whole power 1 power 5 by 2. Upper limit minus lower limit that we have discussed even in the last time. Minus lower limit 0 you apply, children. 0. Again you apply here 0. Clear? Check pa. 1 by 1 power 3 by 2 is 1 ma. So 2 by 3 into 1. Again 2 by 5 into 1. So 1 power 3 by 2 all you know. So take LCM. 2 by 3 minus 2 by 5. 5 2s are 10. 3 2s are 6. 10 minus 6 is 4 by 15. Clear? Check pa. Then the third subdivision pa. Integral 0 to 4 modulus x minus 2 dx. We are doing x minus 2 equal to 0 ma. X equal to 2. 2 is belongs to 0 comma 4 only. So 0 to 2. 0 to 2 one interval, 2 to 4 one interval. In 0 to 2 take one number. 1 if you are considering now. 1 you apply here. In x minus 2. 1 minus 2 we are getting minus 1 negative. So in the 0 to 2 we are getting negative value now. You have to write modulus x as negative of x minus 2. Why, sir? Because modulus x we are not going to take as it is for integration. Modulus x can be positive x or it can be negative x. So plus x when we will take now, when the x is greater than 0 coming. Minus x when we will take now, when it is less than or equal to 0. So you just apply instead of x the 0 to 2 interval 1 place 0.5 apply 0.5 minus 2 negative 1 you apply 1 minus 2 also negative 1.5 1.5 minus 2 also negative. So we are getting negative. So in that way we are applying the negative of x minus 2. Then plus 2 to 4 you apply one number 3, that is 3 minus 2 positive 2.5 minus 2 also positive. Any intervals you are applying 2 to 4 it remains positive. So just write x minus 2 as it is. This will be follow for all the sum wherever the mod comes, this model is repeated. Instead of the mod x minus 2 we have mod x minus 1 or mod x minus 3 or mod x plus 2. X plus 2 comes now, x plus 2 equal to 0, x equal to minus 2. Accordingly the limit they will give, don't worry. X equal to minus 2 they can't give in this sum because 0 to 4 only your interval. So the minus 2 also will be there in your interval. Clear what I'm talking? Okay, so you are decided how to fix these two things. How we are fixing? Once you just check, we are just taking one number x minus 2 equal to 0, x equal to 2. X equal to 2 belongs to this interval. It should be in the interval. Then 0 to 2, 2 to 4. 0 to 2, you are taking one number. Part number, say 1. 1 we are applying negative. So negative of x minus 2. Then 2 to 4, one number you are taking 3. 3 minus 2 positive. Yes, so positive x minus 2. So how we are splitting, you understood, check my very, very important model. Then hereafter, very basic, I don't want to say anything. Negative we keep outside. X integration x square by 2. 2 integration 2x. Again x integration x square by 2, 2 integration 2x. Upper limit you apply fully. Then minus lower limit. So this we have even done in the last exercise. Upper limit minus lower limit work. Do properly and get the answer full. Do it. If you are not getting this answer, kindly inform. Go for fourth subdivision. Again the same formula, integral, not same formula, not 0 to a, integral a to b. So integral a to b f of x dx is integral a to b f of a plus b minus x dx. So what we going to apply for this sum? First I am finding better a plus b minus x is what? A is 1, b is 5. So 1 plus 5 minus x, we are getting 6 minus x. Oh, a plus b minus x is 6 minus x, like that we are finding and keeping it. Then apply here. So last time where x is there we applied a minus x. Here what we going to do now? Where x place was there a plus b minus x. That means x place you going to substitute 6 minus x. X place what you going to substitute? 6 minus x. Substitute ma. Integral 1 to 5. X place 6 minus x. Again x place 6 minus x. Plus root over 6 minus x place is 6 minus x. Minus multiply inside minus 6 plus x. Plus 6 minus 6 gets cancelled. And we have this value. Then what we are doing? Root over 6 minus x plus root over 6 minus x. The plus 6 minus 6 gets cancelled. We are getting root x. Taking it as a first equation. Already we have one equation that is nothing but this. Integral 1 to 5 root x plus root x 6 minus x. So this both we going to add it now. Now first equation plus second equation we are adding I plus I. Integral 1 to 5 root over x plus root over x plus root 6 minus x dx. Again integral 1 to 5 root over 6 minus x plus root 6 minus x plus root x. Clear, check. Then I plus I 2i ma. So the denominator is common. Root over 6 plus root 6 minus x. Numerator root over x plus root 6 minus x. Can we get cancelled ma? If you are cancelling now, you are getting 1 pa. So when we have 1, so kindly integrate 1. So what is the 1 integration? X. One of the easiest thing. Upper limit minus lower limit. Instead of x 5, then minus lower limit instead of x 1. Nice, no? 5 minus 1, 4. So always remember, whenever we are adding like this model, sir, always will return add, sir. I have one doubt. How do I know I should add? How do I know? Like previous sum, we are just integrating directly. So after adding after getting the equation, after getting the property, the second equation, this you are getting like, can you integrate this directly? If you can integrate this directly, integrate it and proceed. If you can't integrate, then go for the addition. What I am saying somewhat understood, because if you see the third subdivision, even I have taken same applying first equation and all I considered. Then after getting, I got this. After applying this, I got this. Okay, wow. So after that, I don't want to add because once I multiplied, I can get simplifier and doing. The same way I applied a minus x or a plus b minus x, whatever. But here, it's not necessary. So what I have done, I have just applied directly integrate. But in this sum, can you integrate this directly after applying the integrals? Can integrate root 6 minus x plus root over 6 minus x plus root x? Answer is no. Then you add. So just applying the property doesn't means. Then after applying property, sometimes we can directly integrate like that sum. But here no. So we are adding and we're getting 1 and we got the answer 2i. So literally 2i we're getting. So I equal to 4 by 2. Remember, some people they won't write that left hand side I. So it will be challenging for us. Then fifth one, again say easy. Integral 0 to a f of x dx. Integral 0 to a f of a minus x dx. Like this comes from property you're going to apply in itself. Make sure the question you take it as a first equation always. Previous sum also like that only. Here also first equation. Once you're taking this as first equation. Again, good news is here a is a itself. So where a is there you apply literal a. So a instead of x place a minus x. Again x place a minus s. Yeah, a minus x itself there. Again x place a minus x. So what are you going to do? X place a minus x power 2020. Again x place a minus x. Then a minus again x place a minus x. The minus you multiply inside now, minus a plus x plus a minus a gets cancelled. So we got this as a minus x power 2020, a minus x power 2020 plus a minus a gets cancelled. Again x power 2020. So now denominator will be common for both. If you want to see first equation and second equation we have added. When we are added, you are seeing now x power 2020 plus a minus x power 2020. A minus x power 2020 plus x power 2020. We are keeping the denominator common. So numerator x power 2020 and a minus x power 2020 both we are adding. Cancel both and getting it as 1. Like a last sum. 2a equals that 1 we are getting now. Then 1 integration is x. Correct, Amma? Then x you are using the limit upper limit minus lower limit a minus 0. So 2i only a. I equals multiplication 2 comes inside now division. Easier check. Then sixth one. I equals to integral 0 to 4 modulus x plus mod x minus 2 plus mod x minus 4. So x equal to 0 I can keep x minus 2 equal to 0 I can get x equal to 2. X minus 4 equal to 0 I can get and do it x equal to 4. We have more ways to do this sum. One of the ways just in that interval everything we have to do. That means 0 to 2 is my interval. In that 0 to 2 interval, this is what? Positive or negative. Apply. For example, 1 I consider 1 you apply in the x, positive plus x. 1 you apply instead of within the 0 to 2. You can apply 1 minus 2 negative. So apply 2 minus x. Understood, ma? Integral at 0 to 2 interval, these values are positive or negative. Again 0 to 2 we taken 1. 1 minus 4 definitely negative. So instead of x minus 4 write 4 minus x. Then 2 to 4 say 3. 3 apply literal positive x. 3 minus 2 positive x minus 2. 3 minus 4 negative 4 minus x. Did you understand how we are doing? Then next easy only. Then plus x minus x gets cancelled. 2 plus 2 4 6 minus x. Again plus x minus x gets cancelled. So x minus 2 plus 4 is plus 2, x plus 2. So easy ma. Here after normal integration. 6 integration 6x, x integration x square by 2. X integration x square by 2 plus 2 integration 2x. Do upper limit in 2. Again here 2 square is 4 by 2. Lower limit is 0, so literally 1 0 is enough. Again here upper limit 4 square 16 by 2. Then again 4 2 4s are 8. Minus lower limit here not 0, it's 2. So 2 square 4 by 2 plus 2 into 2. This step is very important now because even in consumer surplus, producer surplus when you're doing also, we're going to discuss there also we have the lower limit 0. So lower limit 0 now, the second place literally will has to write 0. But you see here the lower limit is 2 now. So we have to apply the 2 properly here. 2 square 4 by 2, 2 2s are 4. So always remember properly do when the lower limit is not 0. Don't granted like all the time it's 0 like. So simplify, we're getting a 12 minus 2. Here 8 plus 8 and if you cancel here 2 plus 4. So normal simplification ma upper limit minus lower limit. So at last we're getting it as 20 as answer. Next, today 7th subdivision is the last in this video. So integral minus 2 to 2, 1 by 1 plus root over e power x dx. Considering root over e power x as t children. So apply if you are squaring on both sides, because we don't want to keep that root e power x as it is. 1 by 2 root e power x and e power x differentiation like that and that. So for removing this, we are taking squaring on both sides and we got e power x as t square. Once we got t square, then it's easy. Then go for t square differentiation 2t dt by dx. Division dx goes it's a multiplication. So e power x dx is 2t dt. Once that is over, then applied multiplication e power x from this division 2t by e power x. Then e power x value is t square children. Then t and t square gets cancelled. Dx is 2 by t dt. Then hereafter just substitute the x value and for minus 2 and get the t square value. What and all we got? Root over e power x, x place minus 2, root over 1 by e square, root 1 by root e square cancel. Same way you do for t square, x plus 2 you substituted now, then we are getting it as e. Substitute this value children. I understood what we done. X value we substituted in that irrespective of t and we got this 1 by e and e. 2 you keep outside ma. 1 by t into 1 plus t, we can use partial fraction or we can write directly 1 by n into n plus 1 as 1 by n minus 1 by n plus 1. Then start applying 1 by t minus 1 by 1 plus t. 1 by t integration log mod t, 1 by 1 plus t integration log mod 1 plus t. E and 1 by e. Log a minus log b is log a by b. So log t by 1 plus t. T place you apply ma e, log e, again here e now 1 plus e, log e by 1 plus e minus log 1 by e by 1 plus 1 by e. Then e by 1 plus e and here 1 by e no, so here kindly take LCM multiplying with e. Easy ma. Again upper limit plus minus lower limit, that all properly do na, it is easy. Simplify it properly. Then 1 by e, the e plus 1 by e comes here na, e by e plus 1. E gets cancelled. And we got here log e by 1 plus e minus log 1 by e plus 1. Again log a minus log b, log a by b. So 2 into log a by b na, I just make for our understanding division symbol. Okay, so division come as it as multiplication now, 1 by e plus 1 as e plus 1 by e. Both cancel, getting log e value is 1. So 2 ones are 2. Clear, check children.